All right, so let's begin today's session. Again, those of you who just joined, my name is Chatura. I'm one of the field engineers for Intercat based in New South Wales. And today's webinar will mainly cover equations and configurations, which is a very useful aspect of SolidWorks. I'll be using SolidWorks 2017 for this application, but even older versions are able to execute whatever features I'll be covering today during this session. Right. So mainly why we use equations in SolidWorks design is to maintain the design intent. So what is design intent? So basically, it is how your model behaves when you were to modify any dimensions or features. So it's more likely when you design something for the first time, you'll be going through multiple design iterations, and when you change a dimension of one of the base features, you would expect the rest of the features to cooperate and adjust accordingly. So equations are very useful in terms of linking features and sketches so that they would update automatically once you modify a single dimension or feature. So to give you a demonstration of that, let me open up one of the very popular tutorials available in SolidWorks. So all of you have access to this. This is hinge. So basically what's happening here is I have a single hinge component, as you see this is an assembly, but if I were to modify one of the parts of it, edit, and I'm going to change the base dimension. It's 120 at the moment, so if you have instant 3D turned on, you know that you can drag and change the dimensions. It adjusts the whole position and also the cuts within the barrel accordingly to accommodate the dimension variation. So this was done primarily by using equations. And when you modify one part in the assembly, the other part gets adjusted automatically. So this was done using configurations, and I'll shortly explain how it is done. So to quickly understand how it is done, let me open up this part. And if I were to have a look at this dimension, let me change it to something more sensible. 120 is good. And if I have a look at the underlying sketch, notice all these dimensions have a little sigma or a symbol in front of it, indicating it's been driven by an equation. So if you were to double click on the dimension, notice it indicates that it's actually dividing the overall length by 5 times to calculate this value. And also even if you have a look at the holes, that's this one. Yeah, there you go. So the whole distance is also driven by a certain equation. So what I've done here is, what the tutorial actually guides you to do here is to take into account the overall length of the hinge and plan ahead to position these holes and the cuts within the hinge. And also if you pay attention to the assembly closely, you'll notice that both these parts are the same, exactly the same part name. It's hinge, and this is called hinge as well, but two different designs. So how this was done is by using configurations. So if you go back to that part, you will notice that there are two configurations in this model. So basically there's one called 2 cuts and there's another one with 3 cuts. So both these were done by using two features which drive the cut features. There's one cut extra feature for 3 cuts and there's one more for 2 cuts. So this tutorial, of course, you can try it out later on after the webinar. But let me use a different example to highlight to you what equations can really do. So let me close all this and let's go back to my slide. And when it comes to equations, it could take into account various things. For example, it can take into account the dimension names to begin with, and also there is something called global variables you could create, which is very handy. I'll explain to you how that can be done. And equations can contain other equations as well, which you have already defined, and mathematical functions such as square root or sine, cos, tan, and things like file properties or the custom properties, and also you can even use measurements in your equations. Let's have a look at one a simple example and see how equations can be used in multiple ways. Select the template, and I'm going to create a quick new sketch. So I go to the top plane and I'm going to draw a rectangle first to begin with. So center rectangle. And as you know, you can add dimensions while you create your model. and let's see how dimensions can be later taken a bit further, and how we can incorporate an equation. So if I were to double click on this dimension, and while the value is highlighted, or if you delete the whole value, and if you click on another dimension while it's active, what's going to happen is it's simply going to follow or copy the value from the other dimension. Notice the moment I delete it and select another dimension, it simply grasps the value from the dimension I've selected and click OK. But there is no link between the two dimensions now. So for example, if I change this dimension to 100, it wouldn't change the dimension which I tried to link. So you have to always make sure when you edit the dimension, and if you want to link it to another dimension, press the equal sign and then select the next dimension. So what's going to happen is it's going to grasp the dimension name instead of the value. Click OK, and now you'll be able to see this little sigma icon symbol in front of the dimension. So if you modify this length dimension, let's say I want to make it 120, this becomes 120 as well. So this is a very basic level equation. You equated one of the existing dimension to the other. You can take it a bit further. Now I want to make sure this dimension or the width is exactly a half of the length. So just put a slash at the end of the syntax. Make sure this dimension is within the quotes and put 2 next to it. Click OK. Divided by 2. Notice it actually calculates the value accurately. And if you want to change this to 100, this becomes 50. All right, so it's a little bit more advanced equation. So one more thing you should always try to do is always rename your dimensions and sketches to much more sensible names. So basically I can call this dimension length. How you do that is double click on the dimensions to activate it and select this top edit box where the dimension name is listed. I could call it length and click OK. So this I could call width. Right. So the significance of renaming the dimensions will be apparent to you shortly when I come to the next example. Right, so dimension names are hidden by default in SolidWorks. So how we show that up is when you click on this eye here, it's possible to activate the dimension names. So you'll be able to see which one is length and which one is the width. So basically when you double click on a dimension, and if it already has an equation, it's going to get updated, and you know what's happening is, so for an example, if you give this model to someone else to modify, so they would actually know the logic behind this equation. Instead of simply saying a d2 at sketch 1 divided by 2, now we know the length is divided by 2, which makes more sense. And then going a bit further, you can even rename your sketches. So I could rename this to base sketch, maybe. So how you rename in SolidWorks again is simply selecting the entity. There won't be any rename command on the right mouse click menu. Select it, press the F2 key on your keyboard, or you could click pause and click again. That's the Windows shortcut for renaming. So I'm going to call this base sketch. Right. So when I rename the feature and double click on a dimension, notice now it says width at base sketch. So it makes more sense. Right. So when you begin this kind of practice from the start itself, it's going to make your design modifications much more easy and sensible, and you'll end up with a lot less errors, especially when you want to troubleshoot. Okay. Right. So my base sketch is there. I want to extrude it out now. Go to features and go to extrude command. Let's extrude it by around 50 millimeters. That's good. All right. Then afterwards, what I want to do is I want to create a shell feature based on it. So go to shell, select the face you want to remove, and I want to make sure this is 2 millimeters wall thickness. That is done. So later on, what I want to do is I want to drive most of the features in this model based on the wall thickness. So basically my intention is to create multiple versions of this model with the various wall thicknesses, and the internal fillet radii and the external radii, also the rib thicknesses, and all that needs to be controlled based on the wall thickness I'm going to follow. So in order to aid with that process, I'm going to create something called a global variable. So this global variable is essentially going to control most of the features in my model. So I'm going to double click on the shell feature to activate dimension, and double click on the dimension, give it a sensible name. I'm going to call it wall thickness or something like that. And also I'm going to create a global variable on the spot. So how we do that is you can actually simply highlight the dimension and put an alpha value or any name you like in the edit box. So basically I'm going to type the letter W for wall thickness, and notice it actually gave me a little pop-up icon asking me if I want to create a global variable. So the moment I select it, what's going to happen is it's going to create a global variable and it's going to revert back to the original value. It's not linked yet. You don't see an equal sign there. So what you need to do is you select the dimension again and put an equal sign. Notice now we have an additional menu named global variables, and the one you just created is listed there. So it shows you the global variable name as well as its current value. Select it and click OK. So now it's essentially linked. So the wall thickness, if we double click on the shell feature, it is linked to that global variable, and here it indicates a little sigma icon showing that it's linked to a global variable. So where do you access the global variables from? So basically once you've created it, it has simply disappeared. So if you want to edit it, notice on your feature tree you have a separate folder now called equations, and once you expand it, all the existing global variables will be listed there. And this has a very special purpose. I'll demonstrate to you how it's going to help you later on. And if you want to edit the equations, you can always right click on this folder, go to manage equations, or you can go to tools and equations. So this equation editor is very useful, especially when it comes to creating equations as well as editing existing dimensions. So under the equation editor, you can list out all the available dimensions in your model. So notice width, length, and also the dimension for the boss extrude is listed here as well. So previously, remember I mentioned to you, it's always good practice to rename your dimensions. So the advantage is you can simply come to this equation edit and modify all the dimensions without browsing through each and every feature and sketch in a model level, as long as you know what these dimensions mean. So let's put it to practical use. So what I'm going to do is I'm going to create some fillets. Let's put a radius of 2 for the time being, and I'm going to select this internal edge. Use the selection pop-up box to select all the internal edges. That's done. And this fillet dimension, I'm going to call it, sorry, I didn't intend to edit it yet. Just drag out the dimension, double click on it, and I'm going to call it internal or inside radius. Click OK. And I want to make sure the inside radius is going to be at least 2 times the thickness, so I'm going to do that later. And one more dimension I need to use is for the outside radius. So select all 4 edges on the outside, click OK. I'm not concerned about the value as of now. Double click on it and rename it to outside radius. Right, so you have 2 dimensions renamed now, and I'm going to use my equation editor to add some intelligence to it. So right click on the equations folder, go to manage equations. They're all listed here. So let's start. So my inside radius, I want to make sure it's at least 2 times my wall thickness. So select your W global variable, multiply by 2. Click OK. It's 4 millimeters. And my outside radius always has to be equal to inside radius. I can notice I can directly select from here to add it to the equation plus my wall thickness. You don't even have to type it. You can simply select it from the list like that and click OK, and it gets adjusted. So if you want to have a look at all the dimensions in one go, you can always right click on your notations folder, use this option, show feature dimensions, and all your dimensions will be listed. And notice it actually calculates them accurately. So wall thickness is 2 driven by a global variable. Now the inside radius is 4 and the outside is this plus this, it's 6. So Later on, what I need to do is I need to add a rib. Well, let's do it now, and let's try to make it much more intelligent and automated. Let's select a reference plane based on this face here. So I'm going to make it 30 millimeters, so let's make it 20. Click OK, and I'm going to create a rib on that. Create a new sketch. Let's use a midpoint line, start from the center, and let's create a rib based on it. Right, so the rib thickness has to be, I'm going to put an equal sign. Notice it doesn't always have to be that pop-up dialog box for dimension. You can even do it in your feature manager. You can access the global variables, and I want to multiply the global variable W by 0.75 times 3/4. Click OK, and it creates a rib. There you go, just like that. All right, so let's test it out. I want to create another version with a larger wall thickness. So basically I want to manage equations, change this value to, let's say, 3.5. Click OK. Everything else changes. Notice it actually accurately calculates all the other values without me having to modify each individual feature and adjust the dimension accordingly. So there's a good chance I may have missed out. I could have missed the outside radius value or the rib thickness while changing the wall thickness. So this way, if you have linked it properly, the moment you modify a single global variable, everything else changes accordingly. All right. So if you were paying attention, you may have noticed in the equation manager, there's another section called features. So what does this do? So we covered global variables. We know what the dimensions do. What does this features section do? So basically, you can make it a bit more intelligent by applying a condition. Let's say, for an example, if I want this feature to get activated only if the length is greater than or equal to 100, I could actually apply that condition here. So all you need to do is make sure you activate the features dialog box. The cursor is there, and select the feature you want to control. So while the cursor is here, I'm going to click on my feature tree's rib feature. It gets added. Then it's going to ask you for the condition you want to use. I'm going to go to my functions. Notice there are so many other mathematical functions you could use. I'm going to use the if condition. And if this length, that's what I'm going to add to the equation. So you can even select from your screen. So the length is less than 100. So if it's less than 100, I don't need a rib. What I'm going to do is put a comma next to it and specify what should happen if the command is true. So if it's true, if it's less than 100, I want to make sure the rib is suppressed. And the next comes what should happen if the condition is not true. Put another comma and say that the global variable you want to use is unsuppressed. Click OK, and it'll show you what the current status is. Because it's 100, it's unsuppressed. Click OK. So let's test it out. So I'm going to choose my boost extrude feature, drag it a bit further. Notice the rib still there when it goes beyond 100, but the moment it comes below 100, it suppresses. So this is a very simple application of that feature suppression tool on the equation manager. You can actually experiment with that and modify it to cater for your application the way you want. All right, so these are some of the examples of scenarios where you can use equations effectively. And just to do a bit of recap, let's go back to my PowerPoint slide. Basically, the most important thing is it's always good to dimension your features and give it a proper name, a sensible name, and try to avoid having spaces in between or dashes. So use underscores instead. There's no harm in using spaces and dashes, but the problem is it gets a bit difficult when it comes to troubleshooting later on. So it's always good practice to use underscores in my experience. And also make use of global variables with sensible names so you can understand what it does and what it means later on. Alright, so we'll be coming back to equations to highlight its applications in assembly level in a bit. But before that, let's have a look at some very simple applications of uh, uh, configurations as well. Just give it a moment. Right, so that's all right. So everybody can hear me good as well. Right. Okay. So let's go to configuration. So configurations is another very useful tool or another feature available in SolidWorks, which allow you to create multiple variations of a single part or an assembly within a single document without you having to create multiple files for it. So basically, this is a good example I've come across. So, it is a cover for a boombox. You notice that there are 6 variations of the same part with different features and sometimes different feature sizes. And you don't have to create 6 different files to come up with this design. So basically, you can create all the variations within the same file or the part document itself. So if you have a look at it, notice there are 3 main variations. So basically, these 2 designs use 2 different cutouts for a speaker, and these 2 designs have a 2 different button slot available. So this uses a slot design and this uses a circular hole. And also each primary variation has a sub variation where the volume button is suppressed. So that could be done as well by using something called a derived configuration. And let's see how that is done in SolidWorks. So the main thing you want to do is you have to create all these features in a single part, and then we are going to use a configuration table to control its suppression state. Right. So let's have a look at it. Go back to SolidWorks. I'm going to close this up. Right. So notice in this case, I have all those features created in one single part. Some of them are even overlapping. So what I want to do next is I want to create configurations to indicate each individual feature. So go to your configuration manager, which is the 3rd tab on your side pane. And notice by default, SolidWorks creates a default configuration. You can always rename this. So basically, if you select the configuration name and if you press the F2 key, what's going to happen is it's going to allow you to rename it. I'm going to call it 50A. So that's my first configuration, this one. And I'm going to suppress the features which are not valid for this instance. So basically, the slot holes won't be valid for this case, but I want to get the slot button. That's all right. Okay, there you go. So it looks more like it. That's done. So what I want to do next is I want to create another configuration for 60A. So let's do that. How do you do that is go to your configuration manager again, and you can right click on the topmost level where the part name is listed and go to this option, add configuration. Then give it a name. You can call it 60A. So under 60A, what you need to do is the circular holes are suppressed, but you want some slot holes. Right. But if you come back to configuration manager, you have 2 variations now. 50A is there and 60A is there as well. That's one way to do it. And if you want to quickly create another configuration, you can click and create any configuration from here, or else you just simply select the configuration you want to copy, press Ctrl C to copy on your keyboard, or you can even use edit copy and then simply paste it, or can press Ctrl V to paste. So it's going to create an exact same copy of what you have selected before as a new configuration. You can choose to rename it. I'm going to call it 70A. And here what I want to do is I want to suppress my slot button and I want to get the circular buttons. So I have 3 variations now, 50, 60 and 70 with 3 feature variations. So the primary variations are done. So what I want to do next is I want to create some sub variations of each one of them. So to do this, I'm going to create something called a derived configuration. So what happens when you create a derived configuration within each configuration is it's going to copy all the settings from the existing configuration and create a sub configuration. So I'm going to call this 70B. This I'm going to call add derived configuration, call it 60B. And for 50 also I'm going to do the same, right click on it, go to add derived configuration and call it 50B. So when you expand each one of them, you'll be able to see a sub configuration within each one of them. And the only difference between each primary configuration and the sub configuration is the volume button is suppressed. So without you having to activate each configuration and suppress the feature, there should be an easier way to do it. So what I'm going to do is I'm going to go back to my feature manager and select the respective feature in which needs to be suppressed. So basically that's the control button. And when you right click on it, you will be able to configure the feature. So when you select this option, configure feature, what's going to happen is it's going to give you this little table. Notice all the available configurations in your model are listed here. And you can either suppress or unsuppress it using this checkbox. So I want to suppress this feature in all 50B and 60B and also 70B. And I also want to list out the other features in this table and have a look at its state. It's going to be quite convenient for me if I want to modify this design further. So while this table is active, just simply double click on each one of these features. So they are going to get listed. Select the buttons, that's it, control buttons already there. And whatever the features you don't want, you can simply delete the column from the table. It's going to be there. And also, if you want to access the same view of this table again, you always need to give it a name and save it. If you don't save it, you can't access the same view. It's going to reset. So I'm going to call it, let's say, config setup, and hit the save button. And I should be able to access it later on using my configuration manager. So let me show you. If I click OK, and if I go to the configuration manager, notice now it actually reflects the changes correctly. And notice now you even have something called a tables folder. Okay, so if you expand the tables folder, you can access the configuration setup, double click on it, you'll get that table again, right? So we missed out a small bit. Notice between 50 and 60, there's a size variation in one of the slots. So this is actually 10 millimeters radius, and this is 20 mil. Let's change that. So if you want to add another dimension to this table to vary it, what you could do is you can go to your feature manager and have a look at the feature or the sketch you want to control and double click on the dimension or single click. That would work. Also, if you don't want to suppress or unsuppress it, you can delete the column to avoid confusion and save the table again. And both of the 60 configurations use 20 mil diameter. So what I'm going to do is just select the primary configuration and change its value to 20. And notice immediately the sub configuration changes because it's a derived configuration. Whatever the modifications you do to the parent configuration gets inherited by the child or the derived configuration without you having to modify it individually. So click OK. Let's see how it works. Do a quick rebuild. 60A is done, larger size, and 50A is done. All right. So this is a very convenient way to produce multiple variations of the same part within the same document without you having to create multiple documents, which will be quite troublesome if you're doing manual file management. All right. And another way of controlling these dimensions and suppression state of features is by using an Excel table, or in other words, a design table. So I'm sure there will be another webinar for design table shortly, but I'll give you a little glimpse of it, so how you create that. So if you have already created this configuration setup table, you can automatically create a Microsoft Excel based table simply by going on to Insert, Tables, and Design Table. Use the auto create option, click OK, and you will be able to get this little Excel based table where the values are listed. So how would you unsuppress or unsuppress a certain feature? So the good thing about this table is it has some built-in validation available. You can even create another configuration simply by copying a row. I'm going to call this, let's say, 80A or something like that. It's going to be a derived configuration of this. And when you select a certain field, it tells you what you can do what possible commands or syntaxes it can accommodate, or you can simply use a drop-down box and suppress, unsuppress, and you can even put values in it for the dimensions which we have already linked. That could be done. That's another handy way of doing it. So the moment you create another configuration in the Excel table and return to SolidWorks, it's going to create a configuration in the manager. So when you double click on it, you'll be able to see another configuration which got created. All right. So that was about using configurations to create multiple versions of parts. So the next thing I want to show you before I conclude the session is how you would use these configurations and equations, or even in assembly level. It'll be a very basic level example, but from that you'll be able to get a good idea on how you could merge that into your design process. Basically, this example uses a layout technique. Let me actually close this part. Let me use this simple layout I have created. So what I've done is I've simply created a skeleton part. So what this part has is a sketch which is driven by lots of equations. So if you go to the equations folder, you'll be able to see there's a global variable for the length, and there's a global variable for the width, and there's a global variable called wall thickness. Although there is no shell feature here, I can always create global variables which are not linked to any entity. So for example, if you go to the equation manager, I can create any number of global variables in this part level. So the idea behind this is I want this single layout sketch to drive multiple other parts in the assembly. So I can have any number of global variables which can be linked to the features of other parts which will be present in the assembly which I'm going to create shortly. And also this length, width, and hole diameter, etc. are linked to the length and width of this part, this sketch, and also the hole sizes of this sketch. All right. So once I've created this skeletal sketch, and I'm going to add this to an assembly, how you do that is go to new, make assembly from part. I'm going to use a millimeter template, add it to the origin itself. So my layout sketch is there. So I'm going to create some parts in context. So this is a top-down assembly modeling. I'm going to go to insert components, go to new part, and use the millimeter template for the new part. I'm going to select the top plane, and I'm going to create a new sketch. Use convert entities, and I'm going to extract the chain of the outer edge of the layout sketch. So click OK. So convert entities, as you know, it's going to maintain a link, in context link between that layout sketch of the layout part and the new part which I just created, which I can extrude. So extrude by around 30 mil. Click OK, that's done. So basically now this is a solid block. I want to link, I want to create a shell feature out of it. And the wall thickness, I want to link it to an existing global variable of the layout part. Notice I'm actually editing this part which I just created called part 9, but I want to link its dimension or the wall thickness to a global variable which is coming from the layout part. So I'm going to put the equal symbol. And how do you access the global variables? Notice now the menu isn't there. But remember I showed you whenever you add a global variable to a part, it does create a separate folder within the feature tree of that part. So if I expand the layout parts feature tree, I can access its equations folder, and I can access any of the global variables coming from it. So I'm going to use this wall thickness global variable. Another alternative is you can actually follow this syntax. So basically you have to say the global variable name at the part name and its instance, like that, or you can manually type it in, or otherwise the easiest way is to simply select it from the feature tree and click OK, and it's going to get linked. There you go, it's done. So similarly, if you want to create some holes in it, I can actually create another sketch, and you can always use convert entities, or you can simply use let's say 2 holes, and I'll actually make sure these two are equal, and I'll link that to the global variable of the layout part, smart dimensions equals, and make sure the feature tree is active of that part. Go to whole diameter, click OK. That's done, and create a cut feature based on it. It's done. So I've created one part, done with it. Okay, so I'm going to create another part now. So select the top plane again, and I'm going to go to insert components, insert a new part. It's a millimeter template. Here's a top plane again for the sketch. And I'm going to temporarily hide this part because I want to access the sketch. How you hide is by pressing the tab key, as some of you may know. Go to convert entities, select the chain, click OK, and extrude it out in the opposite direction. And I want to do the same here. I want to create a shell feature for it. Get a shell, and the shell thickness is going to be coming from my layout part. Use its equations, wall thickness, and I'm going to take out that face. Right, so show back the part you just created previously. That's your assembly. So this assembly has mainly three parts. The first one is the skeleton itself, the layout, and two parts I created based on that. So let's create an exploded view. And there you go. So what I want to do now is I want to see how modifying the layout part would modify the rest of the parts in the assembly. So let's do that. I'm going to open up this part separately. Tile it to the side. So if I go to the equation manager of the layout part, I manage equations, and if I change any of the global variables, let's say I want to change the length to 200, and I want to change the wall thickness to 3 millimeters, and the hole diameter I would make it 15. Click OK, and you can actually rebuild the part and come back to this. It'll ask you whether you want to rebuild the assembly as well. Click yes, and notice all the other parts linked to the layout gets adjusted accordingly with the right dimensions. So this is another way of utilizing equations in assemblies, which is linked to an layout part or a skeleton part. This is particularly useful if you are doing well-meant or structural member layouts, and all you need to do is have a single layout specifying the location of the structural members, and you can link it to multiple individual parts, which is driven by a single sketch. All right. So that comes to the end of our session today, and we have some time now